Now that we've cut our geometry to define the fracture area, let's separate out the pieces that we want to actually run our detailed fracture on. Now, you could try just grouping your geometry, ideally by packing it first so that you just have 1 point per piece, and then you could try grouping by either the monster region VDB or the poly version of that. That's not always the most accurate, especially if you start to get some slightly complicated shapes in your sliced up geometry. So we're going to do it in a bit of a safer way. I'm going to group the raw geometry, not just packed pieces, and then for every piece of geometry, I will see if more of the area of that geometry is within the monster region than outside of it. If that's a confusing way to approach it, it should make more sense in just a moment as we set this up. So to start, let's take our sliced geometry and merge in those window frames. So I'll drop in that merge, connect the shader output to that, and go up to grab the window frames from the second output of that split and connect that in as well. And as I mentioned, we're going to be using a check of the area of the geometry to see how much of the area of a piece is within the geometry versus outside of it. So in order to do that, we'll need to generate the area attribute. So create a measure SOP. This will default to the area. In this case, we don't need to worry about accumulating it per piece or anything. We just want the overall area of each polygon to be calculated. So all of the defaults are fine there. And then I'm going to group this geometry with the monster VDB. So I'll drop in that group node, connect our geometry to that first input, maybe rename this group fracture area, and change that group name to fracture area as well. Turn off the base group, turn on bounding regions. We'll be using a volume. And we have to change that to points for our bounding volume group method. And let's connect that to this monster region VDB up here. Now if we go back and display our grouped geom, now we want to expand our VDB a little bit, just in case some of the edge primitives on our cutout area are lying perfectly along the edge of that VDB. Now some of those might not get selected if they're just barely outside that VDB region. So I'll drop in a reshape on that incoming bounding VDB. And this VDB reshape will default to expanding that volume with an offset of 1. And even that little offset of 1 is probably more than we really need. Even a value as small as like 0.5 should be sufficient. We just need a slight expansion to ensure that the points along the edge of that cut area are selected. And now that we've expanded that area a little bit, we can promote our group to prims. So just drop in a group promote, connect that up, and set this convert to be primitives. And it's kind of annoying to try to select point groups in there when it's populated with all the name values on the geometry. So in this case, I'm just going to type in fracture area instead and display that. And you'll see that if there are large prims with only a little point or two inside that cut area, then that entire prim is going to be included in this fracture area group. So if you select this include only elements entirely contained in original group option, then that group promotion will only promote to prims if all of the points are within that bounding region. So now we've got our fracture area group, we have our area measured for each polygon, and now we can do a per piece check to see if most of the piece's area lies within the cut region. So to do that per piece check, let's drop in our for each named primitive and connect our group promote to that. And then inside that for each loop, we'll use a split on that fracture area. So connect the begin to that. I'll call this split fracture area, and we'll select that fracture area group from the drop down here. In this case, this entire piece lies within that fracture area. This will make more sense for the pieces that are partially inside, partially outside. But in any case, we're going to measure the total area within versus the total area without. So you can create an attribute promote, and we're going to call this area to detail because we're promoting from prims to detail on that area attribute, which you can select in the drop down. And of course we have to connect that to our split in order for that drop down to find the attribute. So select that and make sure, and this is very important, that the promotion method is sum. So in this case it'll find the total sum area of all of the polys that are within that fracture cut region, and it'll create a detail attribute, which if you go to the spreadsheet, go to these detail attributes here, you can see in this case the sum is 786 units. And we'll just copy this attribute promote for the other side of that split, connect the split's second output to that, and then we can use a wrangle to compare these two areas. So I'll just drop in that wrangle node, and because we only need to run this check once per loop, we don't need to run the wrangle multiple times, to evaluate for each point or each polygon. I'm going to set this run over parameter to detail. You can see this tells you it'll only run it once, and then we'll connect the attribute promote to the second input and the other attribute promote to the third. And I'll call this wrangle set fracture attribute. And then in the wrangle, we're going to set some local variables for the area from each of those inputs. I'll say float area A equals, that'll be a detail lookup from input 1 on the attribute called area, and we'll just specify an index of 0 since this is just a float and not a vector or a matrix or something. And I'll copy that and paste it to create a variable called area B. Just point that to input number 2 instead. And then we'll create an attribute on our geometry. It'll be an integer at fracture. And I'm going to set this by using a conditional statement here. So I'll say that's equal to area A is greater than area B. Now conditional tests like greater than, less than, equal to will return either 1 if that test is true or 0 if it's false. So that's a convenient way to set integer attributes like this so that you don't have to use a multi-line if-else statement or something like that. So in this case, if you right-click on that wrangle and go to your detail attributes here, you'll see that's creating a fracture integer attribute with a value of 1. And with detail attributes, if we go to the end of this loop here, you can only have one value on the entire geometry. So after this loop runs, you can middle mouse on here and see we just have that one overall fracture value for the entire building geometry. But we really need this to be per piece. So before we finish that loop, we're just going to promote that detail value down to the prims. So just drop in an attribute promote, display that, select the original class as detail, the new class will be primitive, and select that fracture attribute from the drop down. And because there's only one value for this detail attribute, the promotion method doesn't matter as much, but I often just set it to first match for cases like this. And I'll rename this accordingly, fracture attribute to prims. And then after the loop, I'm just going to do a little bit of cleanup. We're going to remove any of the groups that we've created. So I'll drop in a group delete. And let's middle mouse to see what groups we have on there. It's only the fracture area group and the inside group, but I often like to use a wildcard for the group deletion if I'm sure that I don't want anything except for perhaps inside. So I'll say star, then caret inside, to make sure that it deletes everything except for that inside group. And before I split this into the fracture area versus the non-fracture area, I'm going to add some rest data because it's just always good practice to have this rest data on your meshes. This might come in handy for shading or who knows what else down later on in the pipeline. So now we can split out our fracture area with that split SOP. I'll name it accordingly, fracture area, and we'll say in that group at fracture equals 1. So if you display that, you can see this is grabbing just that piece that we want to run the fracture on. And let's do a little bit more attribute cleanup on this. We no longer need this fracture attribute or the area on all of those pieces. So we'll drop in an attribute delete, connect that up, and then under primitive attributes, I'll put a star to get rid of everything. And then in the drop down, I'll select the attributes that I want to preserve. In this case, name and path. And then in front of those attributes, in order to preserve them, I'll put that little caret symbol so that this is deleting everything but those two. And now with that attribute cleanup done, we can do a file cache on this. Connect that up. I'll call this file cache fracture section. And we want this to just be a single frame cache. So change the frame range to save current frame. For the geometry file path, I always use the job variable. And in my case, I'm using a caches folder and then building RBD. And I'm calling this fracture section. I'm not going to recache this because I already have a cache there, but you can hit save to disk. And then once you've cached that, turn on this load from disk option. As usual, I'm going to add a null here so that we can get this geometry elsewhere in our scene. I'll just call this out to fracture. And then we can do something similar on the other side of our split. I'll just copy that same attribute delete and hook up the second output from the split to that. And I'm going to add an inside attribute to this geometry. We're not adding the attribute to the other side yet because we'll add that attribute when we do a nicer fracture on this. But since this geometry is not getting a nicer fracture, we can add it here now. And in the pipelines I'm accustomed to, we typically use an integer attribute on all those inside faces so that we can add perhaps a bump texture or a different shader, or it can be used for various other things in our workflow. And we can add that quickly with a wrangle node. Just drop in a primitive wrangle and hook up the attribute delete to that. We'll call this set inside. And in the vex, we'll just say I at inside equals 1. But we don't want to set the value to 1 on everything. In this group, we're just going to select that inside group so that only those primitives in that inside group have that value of 1. Everything else will get a value of 0. And we likely won't need that inside group anymore for this non-fractured geo, so you could just drop in a group delete there as well. So just wire up that group delete and then the drop down, select inside. Now before we cache out this geometry, we should bring in the untouched geometry that we split out at the very beginning of this process. If you remember back at the beginning here, we have this split for this untouched geometry. So we can reference that geometry in down below. We'll just jump down here, and you could drag a line all the way across your network, but I often prefer to just use an object merge just to avoid that crazy spider web in our view here. Call this object merge untouched geom, and in this object 1 path I'll hit dot dot slash outbuilding untouched geom. Display that, and we'll merge it with the rest of our unfractured geometry, like so. And we'll want to set some values for the inside and rest attributes on the untouched geometry as well. So you can just drop in a rest position SOP for that rest attribute. And then for the inside, I'll just copy this set inside wrangle, except in this case we don't want to use any group for this. This doesn't have that group, so you can just delete that. And we're going to set a value of 0 on all of these faces of the untouched geometry. Now you can display that merge node, and we'll create another file cache for our untouched geom and connect that up to the merge. And as before, we'll flip our valid frame range to save current frame. And in the geometry file, we'll go to our job variable, caches, building RBD, and I'm calling mine non-fractured section. And then when you save to disk, you can flip it to load from disk and check out the results. And it's always good to make sure that your inside attribute in particular is set correctly on your geom. It's a real pain if you don't realize until later on while working on the shot that this is wrong, and it's much easier to fix it now than later. You can check that out with either a color node or a visualize node. In this case, I'll use visualize. Under visualizers, you can set the color type to a ramped attribute, and the attribute is going to be inside, and we'll flip that attribute class to primitive. If you scroll down to the color ramp here, you can see we're getting a value of blue on all of the outside faces and red on the inside, so it looks like everything is being set properly. And of course, as the final step in our building split here, we're going to add a null for our untouched geom cache, and we'll call this out static building.